I've just written topic like this one by one. So let's understand them one by one. First, we'll talk about data engineer. So you can see here, what is data engineer? How we can define data engineer, right? So before understanding data engineer, we talked about that there are three types of career options is there in data-driven technologies. One is called data analyst. Second is called data scientist. And the third is called data engineer, right? So let's see one by one. If we talked about data analysts are those guys who generally deal with historical data. They try to do, sometimes we define them as virtualization engineer. They generally use historical data and they try to present those historical data using Python libraries, as in pie chart or bar chart. The main purpose is to deal with historical data. On the other side, data scientists, what they do is that they collect historical data and predict future model. That means data scientists are responsible to apply AI/ML algorithms. You can think about AI/ML algorithms or deep learning algorithms. Right? They generally deal with that. And that is completely based on Python, is much more popular because most of the open source libraries support Python. Next, we are talking about here that then how you can define, then what is the task of data engineer? So this is the ability to build an application that handle large amount of data and derive insight from the data in automated way. That means large amount of data means we are talking about big data and derive the insight from the big data in automated way using AI/ML. Yes, data scientists mainly use AI/ML, but data engineer can also use AI/ML or they can take help of data scientist. Most of the time, data engineer knows AI/ML also. Right? So this is the skill, and this skill is called data engineer. Because today business is using huge amount of data, it's continuous stream of data, big data. So how to store big data, how to analyze big data. It's a how to migrate big data. So it's a deal, it's a task of data engineer. Now we can see if I say some of the tasks of data engineer, like we have to migrate big data from source to GCP, we have to analyze big data, to send the data from one services to another service, we create a data pipeline and we apply AI/ML to big data to retrieve values from the big data. These are the major tasks of data engineer. Right? Now here, if you see, if you want to go with the data engineer task, you know, the things that come first, that is called big data. You should know some points about big data. Though the slides are more content, but this session is not for big data, but we should know some points about big data so that we can understand GCP Big Data Services. From that point of view, I'll go with some slides. Now you can see here, what does it mean by big data? Anything that is raw is called data. When you process the data, you get information. So when you process the data, you get information. So any data that is beyond the processing capacity is called a big data. Assume your manager told you to store 1 petabyte scale data in your external hard disk because we need to do some task tomorrow. But how to store 1 petabyte scale data? Your mobile, traditional mobile device or external hard disk also, if you use, or some other server also you use, you cannot store 1 petabyte scale of data. That is beyond human capabilities, right? So how to deal with the big data? When you talked about big data, we are talking about brontobyte, yottabyte, zettabyte. Today's industry is dealing with zettabyte. And day by day, this use is going to increase, right? So how deal with this big data? Big data means the data that is generating from different types of applications. When we talk about big data, 4 V's come into picture: volume, that is increasing in size; variety, there is different types of data, some are structured, some are semi-structured, some are unstructured. Then, as I told you that the big data is something that is continuously flowing from one source to another source by 24/7, right? So that is coming first, right? And the data that is biased, free, trustworthy, right? So this 4 V come into picture to define big data. Now, I'm just giving just to show an example that how business use data engineers to get the profit. Just one case study. If you see Netflix, the same organization that you do subscription, right? So Netflix is one of the greatest provider of commercial streaming videos in US, as you know. Now this Netflix, it receives huge volume of behavioral data. What does it mean? Data engineers who is working in Netflix, what they try to check with the help of data scientists is that when users watch a particular show, where do they watch it? On which device do they watch the show? How often do they pause a particular program? How often do they rewatch a program? Do they skip the credits? What are the keywords searched? These are some of the decisions, some of the answers that will help business to take business decisions, and that is related to profits. So that is the task of data engineer, one of the tasks of data engineer with the help of data scientist, right? Related to big data. Now the question is that when just now told you, big data is something that you cannot store with traditional. I'll not say too much in depth because our focus is not big data, but some familiarity. So I'll move with the slide first. Now, how we can store big data, how we can analyze big data. So this process started you creating a distributed system. A distributed system is a model in which components located on networked computers communicate and coordinate their actions by passing messages. So the approach started to create a distributed system to store big data as well as to analyze big data. Now there is multiple challenges related to system failure, bandwidth issue, high programming complexity. Multiple challenges was there to deal with big data in distributed environment. Then Hadoop came into picture. You may know the name of Hadoop. Hadoop is an open source component to deal with big data. So Hadoop is used to store big data, to analyze big data. It's an open source component. If you see this person, his name is Doc Cutting. He was working in Google earlier. in Google file system to deal with big data. Now, he has an excellent, we can say, involvement related to creation of Google file system to deal with big data in Google. Then what he has done is that Google file system is a specific vendor product, right? So he left Google, he joined Yahoo. And when he is working on Yahoo, he created a big data solution. Its name is Hadoop. So Hadoop, this big data solution created in Yahoo, and later it becomes an open source, right? And so, so, so that Hadoop have multiple characteristics to deal with big data. I'm not going in depth outside. Now, there is some difference between traditional databases with big data, Hadoop. In traditional databases, we have some limit, right? Yes, I can store 60 GB data, right? Or 50 GB data, something like that. But Hadoop is something that can store big data, unlimited data. That was one of the solution came from docketing in Yahoo. Now, Hadoop have multiple components. If you see, there is different components are there. Some components used for data analysis. Some components is used for programming. Some components is used for data exploration. Some components is used for data ingestion. Some components is used to store the data. So there is multiple component if you go with Hadoop. So let us talk about some points. Introductory point. HDFS. It is a file system that is used to store big data. We have another one component called HBase. It's a NoSQL database for non-relational database to store data in HDFS. We have another one Hadoop component called Scoop. It is tailored to design transfer of data between Hadoop and relational database servers. We have another one component called Flume. This is also used for ingesting streaming data suited for event data from multiple systems. We have another one component, Spark, very popular component to deal with big data. It's very powerful component, Spark. We can process big data using programming with Spark very fast. Business use Spark. It's an open source component. It will come with multiple components. Before Spark came, MapReduce came. It is also used. It's a framework to that process big data. But Spark is much more faster than MapReduce. We have Pig that is mainly used to analyze your data. We have some component called Impala that is also used to analyze the data, mainly with the SQL engine. We have used another component called Hive. Its main purpose is to execute queries with MapReduce. We have Cloud Data Search that is used to real-time access of the product. Now, if you see this is the full, different component of Hadoop that deal with big data. Now, I will say that why I'm talking about it when I'm talking about GCP Big Data Services, because GCP Big Data Services has lots of similarity with Hadoop. So what you find here in this, these are the different services from Hadoop. Different component have different tasks. Some component is for ingestion, some component is for processing, some component for analyze, and some component for accessing. Right now, if you see here, now the question is that here, if you see one of the component is their cloud data. See, whatever you find in the Hadoop, solution to deal with big data, all are open source. When Docketing created it in Yahoo, after that they make it open source so that business can use it. But if you want to use Hadoop in open source, you should have a good technical team with good skill set, correct skill. Then only they can configure it. And if you don't have a skilled workforce to configure Hadoop, in that case, Cloudera come into picture. Cloudera will take some price and they'll give you an excellent Hadoop setup to deal with big data. That's why Cloudera, you may find this Cloudera have multiple brands throughout the world. Now here, now I'm moving towards GCP Big Data Services. We got some idea, right? I'm not going in depth. Yes, we got some idea. Yes, this is Hadoop as an open source solution to deal with big data. Now this Hadoop, how it is connected with GCP Big Data Services, that we are talking about here. There is lots of similarity. Just see here. If you see here, we are talking about big data services from GCP. Big data services from GCP, name of the services are like BigQuery, PubSub, Dataflow, Dataproc, Dataprep. These are all big data services from GCP. If you want to see these big data services, if you just see here in the left side, here if you see in the left side, you'll find these services go down. You can see here down. Dataproc, PubSub, Dataflow, BigQuery. These are some of the popular big data services from GCP. Okay, some of the popular services we're talking about here, right? So we are talking about here. When I came here, big data services under GCP, we have to familiar ourselves with these services. And we have to compare these services with Hadoop provided services. Then it will give a very good understanding. Right? So you can see here, GCP Big Data Services. On the other side, we have Hadoop open source services. To analyze big data, data per second, store big data. These are the things that we do in GCP Big Data Services. Whereas now here, what you're talking about is that if you see here in this example, there is a big data service. Its name is BigQuery. You have not written it here. Its name is BigQuery. BigQuery is a popular GCP Big Data Services. BigQuery. So BigQuery is one type of data warehouse. Data warehouse means database plus reporting tools. Both will be there. You can store big data as well as it have an excellent reporting tool that is called BigQuery. It is one type of analytical database. It can stream data at 1 lakh row per second. It can store big data, fully managed. It's support. It can store the data. This service can store the data in petabyte scale. Low cost analytics data house, you can say. Right, BigQuery is automatically enabled for your project. So this is one of the popular service in GCP that is going to store big data, analyze big data. And the equivalent service in Hadoop is, its name is Imbola. It is equivalent service in Hadoop in open source. It is not open source, it's a big GCP Big Data Service. Let's see another one. We are talking about PubSub service. Remember last day, we have used PubSub, right? GCP PubSub. That GCP PubSub is nothing but one type of GCP Big Data Service. If you remember in the last day, we have created topic, right? So this using in the GCP PubSub, we have created topic and subscription, right? So this GCP PubSub service, it is one type of GCP Big Data Service. Its purpose is real-time messaging service, right? We can say it can send 1 million message per second. This GCP PubSub service. So fast, it is scalable and flexible enterprise messaging service. It will allow you to send and receive message between independent application that we have done last day, if you remember. Right, publisher is sending the message inside the topic, right, and consumer is going to consume the message inside the subscription, right? So it can send 1 million message per second. So think about so fast. It will allow, you know, subscriber, right, to subscribe the message that is coming from the publisher. Same example that we have done last day, right? Can be used for multiple. So one example hands-on is BigQuery, and get a full idea how the message is going on, how I'm going to analyze that message also. So here, this is a PubSub message. This is from a big data service. An equivalent solution that come from Hadoop is HSMF, Hadoop Secure Messaging Framework. Now we'll say that why I'm moving, comparing the services with Hadoop, because of this. One of the another open source solution is the Apache Kafka. That is also an open source solution to deal with real-time messaging service. Now here, on the left side, there is some services called data flow service, data proc service. These are from GCP, data flow, data proc. What are the purpose of these services? You can see in the equivalent Hadoop service is MapReduce or Spark. This MapReduce or Spark mainly, this is a programming layer in our Hadoop. So using MapReduce and Spark, it is a programming model for both stream and batch processing. Now it will allow ETL also, and same task provided by GCP Big Data Services. Its name is data flow. Provide one type of programming model as Spark and MapReduce provide in Hadoop for streaming and batch processing. We have another one service called data proc. Now, just now told you that sometimes, see, Hadoop provided services, they're open source. Whatever services we are talking about, they're open source. Open source. So sometimes you can call these open source services from GCP. So if I want to call this open source services from GCP, I can use data proc. Data proc is one of the services from GCP that is used to call open source services in Hadoop. It is used to execute Hadoop provided services. If I want to call Hadoop provided services from GCP, I can do that. How I can do that? I have to create a Dataproc cluster, and in the Dataproc cluster, all the Hadoop libraries are there inside because Hadoop is an open source, right? You can take it inside. Similarly, we have data prep. Data prep, this is also one type of intelligent data service, data prep, for visually exploring, cleaning, and preparing structured and unstructured data, reporting as well as applying ML. So these are different services are there. Let's explore them. In this slide, we just given some comparison. Let's explore them into more depth. Now see here, just now told you that big data solutions. Big data solutions are BigQuery in GCP, Google Cloud Data Flow, Google Cloud Data Proc, Google Cloud Data Lab. These are the different services are there in GCP to deal with big data. Now here, I'm talking about some other services. We have Google Cloud PubSub, Genomics. Now you can see fully managed enterprise data warehouse for large scale data analytics. I'm talking about this BigQuery. service. BigQuery is a Google's fully managed petabyte scale, low cost enterprise data warehouse for analytics. BigQuery is serverless. There is no infrastructure required to manage. You don't need a database administrator, so you can focus on analyzing data to find meaningful insights inside using familiar SQL. So this BigQuery, it is not Google BigQuery service. It is neither not a single database also, but also it is incoming. It is one type of data warehouse. It is connected with some reporting tools. I'll share with you. It's a very popular service, excellent service it is. Next, similarly, we have it has some features you can see, but if you do some labs, then it will be more clear. For this, we have this is other side. I'm coming into that. For this, we have Bigtable. Now here, Google Data Flow. Purpose of data flow is that it will give one type of programming model for to deal with big data. It will allow to create some ETL computations also. It support one type of Apache Bean is one type of SDK. Using this, it will give us one type of programming model, and programmatically you can deal with big data with the help of this Google Cloud Data Flow. Similarly, we have some other service. Just some features of this. We have some other Google Cloud Data Flow service, how it work. They've given some thing when the data is coming, it will pass through a stream or batch. It will come to the Google Cloud Data Flow. From the Google Cloud Data Flow, the data will go to either BigQuery for storage and analytics. For analysis, it can go to Google Machine Learning. And right, if the data is unstructured, in that case, data will go to Google Cloud Bigtable. Bigtable generally store unstructured data, right? So this is some scenario, right? How to deal with the big data, right? Now, data proc. Just now told you that it is, we generally create one cluster of data proc to connect with Hadoop provided services. That's why I'm going to Hadoop. If I want to call Hadoop open source services from GCP, then I need this service, data proc service. Generally, we have to create a cluster. Inside a cluster, we use Hadoop provided libraries. We'll execute a service as a batch inside that particular data proc cluster. Generally, we implement like that. Similarly, we have some more services like Google Data Lab. Now, this Data Lab, it is a powerful interactive tool that is being used to create and explore, analyze, as well as transfer, as well as visualize the data using some ML model. Similarly, we have PubSub. PubSub we have seen last day. Main purpose of PubSub is to send the data at a scale, real-time streaming if we want. Some real-time data is coming from one source. Always the data should come inside a PubSub, and from that PubSub, it will go to some other component. Always, if some real-time data is coming, continuous flow of data, always we take it inside a PubSub. Then we have some other services like you can see here. When the real-time data is coming, generally take it inside a PubSub first. So inside a PubSub, already you know the data is coming inside a topic, right? And we subscribe to that particular topic. It will go there. Then data flow service will process the data and send it to a specific service based on the type of data, right? It will go to a specific service where you're going to store it as well as analyze it. Now here, now see here, these are the GCP provided services. Now see, yes, I'm talking about theoretically, but we should execute, we should see one service, how it works. That's why I've just selected one of the service. Its name is BigQuery service. Let's work with the BigQuery service. How I can use BigQuery service to deal with big data. So let's see here. If you want to use the BigQuery service, in the left side, you will find BigQuery. See here, BigQuery. And this is the BigQuery Studio. I'm coming to BigQuery Studio. I'm dealing with BigQuery service. And what I'm going to do is I'm going to do this task using BigQuery services. Control C, I'm coming into this. So this is my BigQuery. When you came inside the BigQuery, you will find it like this. BigQuery Studio. And here you can, I'm just closing something that is not required. Here on the right side. So this BigQuery Studio here, as for example, in case of relational database, right? What you do, we have a schema, right? Inside a schema, you have some table in case of relational database. But in case of BigQuery service, just you can compare that. We don't use a schema. We use the concept called data set. This is a data set. This is a data set. You can delete this. This is a data set. So we have to remember that in case of BigQuery service, you can store some data inside a BigQuery service as you do store data in relational database, right? Inside a schema, you have multiple tables. Similarly, here we inside a data set, we have multiple tables. So just see here. And here you can write some SQL queries in your data set. Right. So I want to show you one demo. To show you a demo, I'm going to use one data set. The name of the data set is, we have some names. All our names. This is my GCP provided service, right? Now, how to work with the data set in GCP? So to work with the data set in GCP first, in a BigQuery service, first what you have to do is that I have to create a data set. I have to create a data set, right? So how to create a data set? I'm just doing the first task. Create a data set. Task 1. How to create a data set? Is that here? See the option. There is an option called create data set. Right. So I'm creating data set. When I click create data set, it will tell you to write the data set name. I'm writing the data set name as baby names. This is the data set name. And I want to create this data set. Now its size is in KB. It can be in TB. It can be in GB. Now I want to make it as a multi-region. Already you know the advantage of multi-region is that it will give higher availability, right? If you go down, it is saying that create data set. Let's create this data set. You can compare this data set with the concept of database schema, just for comparison purpose. So I've created one data set here, right? This data set just now we have created. You can see this is a data set name created this time, right? So that's it. Now what we'll do is that inside a data set, we create a table. Inside a data set, we create a table. So which data I'll take? I already have shared some. I have created a data set in the BigQuery. How to create a data set? Just you have selected, right click, new data set. Its name is baby names. Data set created successfully. First task is done. If you want to remember what is this data set, from where it came, for this remembering purpose, I'm just saying that it is same like your schema in relational database. Equivalent type, right? First data set created. I think it's created for everyone, right? Second step, create a table and upload the data from the file just now I have shared. You can download that file in a folder. So second step is create table and upload the data from the file.
Okay.
So I'm creating the table. Just select the data set in the left side and select create table. So if we click create table, just see here, it will come like this, right? Now see the options. First, create table from. I am going to upload a file. I want to create a table from the text file. It's a written. Create table from. I'm going to create a table from a text file just now you have downloaded. So you can select here upload. When you select upload, it will give option to upload your file. Go browse and here select that file where it is inside your GCP Essentials. This is the file and open. I've opened this txt file. Then next step, I'm going to give the file format as CSV. Right, so there are three things we have done. Destination project as it is, leave it. Baby names, the table. Okay, so we have selected the file format as CSV, right? That means what? We are getting the data from the text file into my BigQuery service inside the data. So I'm getting a table. Now here, the table name you have to provide. You're going to get a table, right? So there should be a table name. I'm writing the table name as names underscore 2024. This is my table name, right? Fine. Next, it is saying that the table type. So native table. When the table type, there is different types of table type. Native table means the purpose of native table means you are going to create. You have to uh, edit as text, because if you see the file, just see this file. Let me just show you the file. This file contains three parameters. One is string. Second one is also string. Third one is an integer. Three parameters is there. So these three parameters should come inside it. What is the first parameter? First parameter is name. Small letter. Colon. What are the data types for the first parameter? String. In XML, string S should be small letter. Right? First parameter is done. Second parameter is what? It's a gender. I'm typing the column name. Gender is what is the data types for gender? String. String is a small letter. Then third parameter. I'm writing the third column. Yeah.
We have to put the comma in between.
Yes. Yes.
And a space or
You can use space as it will count. If you have multiple space, it will count as a single space. It can identify. You can use count. Count is a column name. What are the data types? Integer. If you don't want to give a space, that is also fine. You can just don't use any space in between. There is no space in between. So what I have defined, three column type name for the first, second one is gender, third one is count. Three column I have defined inside my table, and so column and its data types.
Declaring all the variables
And its data types, right? Fine. So this task is done. I'm getting a table. Just see here all the data from the text file. It will come inside your table. See the table is created, and you can just see here all the data from the text file. It will come inside your BigQuery. How to see? Click preview mode. See here all the data came from the text file inside your table, inside the dataset webinars. Check it's working for everyone.
Okay, go to table.
Table, then
And
preview. Check if it is working till
oh,
here.
go
That
go to
means
table. Oh, table. We have to click that tables. Okay, and then
so how I can query the table using SQL. So here, so this is our data schema, details, preview, right? Here one option is there called query. Just click query, a new tab. When you click query in the new tab, it is saying CS, it is automatically generating some SQL query. Select star from project name dot it's called project name dot dataset name dot table name, and it is coming by default. I'm not written anything. Select star from table name with limit this. So we can fire an SQL query, and that SQL query is going to get the data from your files, from your table. In this example, it is table, right? In BigQuery, it becomes a table. Yes, I can get the data. You can try from your end. If you want to select, no, don't want to star. I want to use the table column name. So name, comma, count from table name, limit this. So if you execute, you can see here name and its count is coming, right? Now here now I can apply some condition as we do in normal SQL queries. I can apply where gender, equal to M, right? Order by, you can apply if you want order by, else leave it. Let me just check. So based on the gender name, is going to select all the male whose gender is male, all the participants get selected, right? And you can see this is a simple SQL query as you do it in database. Same like that SQL query we can do with the data that is stored inside a data set, inside a table in BigQuery also. Check it should work for everyone. Task 3. So we are talking about task 3, control C, SQL query. You can apply any type of SQL query as you know. Now see here, the big query that we are dealing with, it is not only a data, it is one type of data warehouse. So what is the difference between normal database and data warehouse is that data warehouse will come with a reporting tool. And if I want to generate the data using a particular reporting tool, I have to use in here explore data using Looker Studio. Remember, this Looker Studio is a very common questions in your data Google Digital Leader certification. One questions will must come from here, Looker Studio. What is this? So just explore the data with Looker Studio. If you just open, if you see this Looker Studio is an excellent reporting tool. See here, it will project your data using a graphical format. Right, an excellent tool it is. You can edit, view, you can insert it, you can represent as a page, you can arrange all the fields. You can add another one field, you can add some parameter, you can add some data on the right side, change the properties. You can filter a bar, right? So you can and create an right. So it will give us an excellent tool to deal with. You can save and share it with the teams. So it is a very good, excellent tool. You have to remember the name of the tool is called Looker Studio. It is integrated with our BigQuery service. Just check that you can represent the data using Looker Studio. You can do lots of things, right? That is one scenario. Now, create a reporting using Looker. That is the task 4. The task 5, that is a very important task, is that, see, we talked about we have multiple GCP services. We have multiple services. One of the services example, we are doing it here. That is BigQuery, right? Now see, as we know that whatever the service is there in GCP, right? If you remember in day 1, we talked about GCP services, we can communicate with the GCP services using REST API. All the GCP services we can communicate. Here I'll show you one example how I can communicate with a BigQuery service. How I can communicate with a BigQuery service using REST API. That is our task 5. So if you know how to communicate with a BigQuery service using a REST API, you can communicate with any big service with REST API. Right? So how to do that is that, see, what is our purpose? I want to communicate, I want to connect with BigQuery service with REST API. If I want to connect with BigQuery service with REST API, I have to use BigQuery documentation. For each service, there is a documentation. For BigQuery service also, we have a documentation. So you can see this documentation. Control V. And just open BigQuery documentation. Right? Now the point is, what I'm going to do is that I want to insert some record inside the BigQuery. Okay. I want to insert some record in the BigQuery using BigQuery documentation. This is my REST API. You know this REST API format, right? If you just open the link, you'll find. So using this REST API, I want to connect with BigQuery service. Right? So this is my requirement. Right? So if I want to do that, what I have to do is that I want to insert one row inside a table using this REST API. Right? That is our main task. Query using REST API. You can insert, you can update, you can delete, you can select. Right? So in this example, in the task 5, we are going to insert some record using right REST API. So if I want to insert some record in the REST API, I should have a table where I want to insert. Right? So let's create a table. Let's create a table under baby names is the data set. So under baby names, create another one table. There is an option to create table. You can find here. This is my created. Select this data set. Click create table. And you are going to create an empty table. This time don't select anything. You are going to create an empty table where I'm going to insert the data. Use the table name as use any name like my table, something like that. Right? And just enable. And here you can use 2 field. First field is like greeting and it is of string type. Second field you can write target, assume it is also a string type. So 2 column we have created in the empty table. You can use any field as you wish. Right? In the empty table, its name is my table. Right? Create table. So you can see my table is created. And there is no value in the my table. If you go to the preview, no value, it is an empty table. No value is there. Now I want to insert one row inside this my table. using REST API, right? Civil creation is done. Now I'm going to REST API, and this is my REST API. I've already shared the link. I'm going to insert 2 records, right? Now it is saying that you have to define the project ID, dataset ID, and table ID, right? So what is the project ID? Select the project ID in GCP. Go to GCP dashboard. You have to leave everything. You have to go to the GCP dashboard. Check what is the project ID. This is the project ID. Control C, paste project ID. Done. Next, dataset ID. What is the dataset ID? Dataset ID is in your BigQuery, right? So let's go to BigQuery once again. BigQuery Studio. What is the dataset ID? Just see here, dataset ID. This is my dataset ID. Baby names, right? So if you want to copy, or you can write it, dataset name, baby names. What is the table ID? You can see the table ID. My table. My table. That's it, right? These 3 parameters you have to give. Now what I'm going to do, I'm going to insert one record inside the my table, inside the BigQuery. See, this is a REST API. You're completely outside. So if I'm going to insert any value, we should always communicate with the JSON message. That only you are doing it. Automatically, these key things will come. Now now what it is saying is that add request body parameters. Right? I'm going to add the request body parameters. What I'm going to do is that I'm going to add one row inside the table. Select row. Right? So inside a row, I want to insert some data. Right? In which format I want to insert the data? In JSON format. Select JSON. Right? So JSON means what? It contains the value in key value pair. Right? So just select the key and value. So inside this JSON, I have to divide the key value pair. So inside the JSON. This is my JSON. Inside the JSON, I have to define the key value pair. So first key, what is the key? Getting the column name. So for this column name, I want to insert one value. The value is like hello. Second, we have the column name. What is the column name? Target. So for this column name, I have to insert one value. The value is something like that. You can define your own values, but column name should be same. I have used the column name greeting and target. So value as you wish. That's it. This is our JSON message. Right? So if I insert, this value should go in the table. Currently, there is no value in the table, right? Click execute. Check. I'm just communicating with GCP from completely outside. So it is asking me to validate. I have used this email ID for Google Cloud. It is asking me to validate. Allow. Let me check it's giving success or failure. See, it is saying failure. So what is the reason? You can use not found project. So it is saying this project is not available. Why? We have this project, right? If there is any space or not. You have not used. See, I have used some extra space, possibly. I think so. Don't use any extra space. Let me try once again. It should work. See, it is saying success. When you're going to do a copy paste, you have to check you should not have any extra space, right? So it is saying 200 success. That means the value that I am sending using REST API inside my service GCP service BigQuery, it has gone using REST API. Let me check. Let me go inside my BigQuery table. This is my table, right? Select my table and click preview. See where value came. right? So that's it, right? Using a REST API, we can interact with a GCP service, right? But we should have the REST API documentation, and it is working fine.